So this is the gradient function, f prime of x, and looking at the graph, we can see that it is a negative quadratic, so negative quadratic or parabola, right, with that shape. And so we're given the gradient function. The question asks us to sketch the graph of the original function, f of x. So to go from the gradient function to the function, we need to anti-differentiate. Right, or integrate. And the antiderivative of negative x squared would be negative x cubed, so add 1 to the power, divide by the new power. In other words, when we anti-differentiate, we will expect a negative cubic. And a negative cubic has a shape like this, right? It goes from top left to bottom right, where it goes through the minimum first, then the maximum, right? Whereas a positive cubic has this shape. So just with that in mind, we know that our sketch will look like a negative cubic because the antiderivative of a negative quadratic is a negative cubic. But let's now reason about the different points on the function to make that connection. So the gradient function tells us the gradient of the original function for any x value. For example, when x equals 2, 4, 6, the gradient of our original function is 8. So on our sketch, when x equals 2, 4, 6, somewhere on this line, our function will have quite a positive and steep gradient, like positive 8, very steep. Now that point's not super useful to us for sketching. What is useful to us is when the gradient is equal to 0. So on our gradient function, that corresponds to these x values of 2 and 10. All right, or the second and the 10th grid line. So on our original function, just to help us with the sketch, I'll put in a dashed line. When x equals 2 and x equals 10, our function will have turning points in line with those lines, because the gradient function, the output, the y value is 0, which is the gradient of our original function. Okay, so we know it's going to be a negative cubic, and we know our turning points, our min and our max, need to go through those red dashed lines. And that's all we need to sketch it. Now you may be asking, but how do I know how high to position it? For example, should it be like that, or that, or how steep should it be? Right? All of these things are possible with the information we are given. Usually, they would say, given it passes through, let's say, the point 0, 0. So if they give us a point, then we can restrict our shape to look something like that. Right, of course, it is still a sketch. Oh, that's a positive cubic, isn't it? We know it's a negative cubic, so the minimum comes first. Now, again, it is a sketch, so it might not actually be the exact antiderivative. However, as long as the turning points line up with those red dashed lines, and it's a negative cubic, that would be for this question, a merit. If you only got the turning points correct or the general shape correct, that would be achieved. Yep. And let's just double check the gradient function. So between the x-intercepts, the y value is positive, which means the gradient of our function should be positive, right? Which it is, it's increasing. However, outside of the x-intercepts, so before 2 and after 10, the y value of our gradient function is negative, which means the gradient of our original function should be negative, right? Which it is. And of course, the max and the min point have a gradient of 0, so they're in line with the x-intercepts.